SCIENCE.
Hello and welcome to Super Science Saturdays. My name is Sarah Scoggin and I'm the Early Childhood Librarian at Newburgh Free Library, Newburgh, New York. So this month's topic is what I'm calling SCIENCE. So we're going to learn about 7 different science topics or concepts, each beginning with one of the letters in the word science. So let's get started with letter S.
S is for scientific method, first and foremost. What is a scientific method? It's the method that all scientists use, no matter what kind of science they're doing. First, you ask a question. Then you gather information and observe or do research about your question. Then you make a hypothesis. That's a guess about the answer based on what you already know. Then you do your experiments to test your hypothesis. Get some data, they say. Then you analyze your test results. What do the things you learned say about your hypothesis? Was your hypothesis right? Then you present a conclusion and share your results.
S is also for surface area. So here I have a regular index card, and it's about 87.5 square centimeters. That's how much area of paper I have here. So what's the biggest hole I could make in a card this big? You might think I could cut out the middle, and this is the biggest hole I could make. I've taken a lot of that surface area out and just left the frame. What if I told you could spread out the surface area of this card to make a hole big enough to step through? First, you would take an index card and fold it in half, the skinny way. And then you would cut, not all the way through, just a flap on this side, and then you would cut another one on this side. Open it up, and you want to move these little pieces of paper out of the way, and cut down this middle piece, right on that crease you just made. Okay, now I'm going to fold it in half again, and I'm going to alternate. So this time I cut on the top, this time I'm going to cut on the bottom. Again, each time I don't cut all the way through, I just cut most of the way through. So I got on this side, and I keep doing that. I cut all the way up until I get this. If I stretch it out, now this index card is big enough to go over me. I could step entirely through this index card because I spread out the surface area of the card, a much bigger hole than this.
C is for calcium. Here is the periodic table of the elements, and there is calcium with the arrow. The periodic table of the elements is a chart of all the different kinds of elements there are. An element is a kind of material that's only made of atoms of one kind. Everything we can touch and see, and some things we can't see, like air, are made out of different kinds of atoms. So one atom of calcium is the smallest piece of calcium you can have and have it still be calcium.
So C is for calcium. In my opinion, each element is special in its own way. But some elements are really, really hard to find, and others are all around us. So where do we find calcium? Why is it important? Well, you can find it in your teeth. You can also find it in your bones. That's why it's important to eat things like cheese or broccoli that have lots of calcium in them. It's also found in chalk, like you would use to write on a chalkboard. An eggshell is mostly calcium. We don't eat eggshells, but we do eat eggs. And if I had a raw egg, do you think I'd be able to take the shell off without breaking the egg inside? Well, I couldn't just peel it with my fingers that way, but I could dissolve the calcium because calcium dissolves in acid. So here I have what is called a naked egg. It's an egg without its shell. And if you move it around, you can kind of see the yolk floating around inside there. And this is just like the skin that's right inside the shell, we call the membrane. So how did I dissolve this eggshell? Well, I took a cup and I put an egg inside, and it looks like it's water, but it's actually a cup full of white vinegar. And vinegar has something in it called acetic acid. And that dissolves the calcium. So I put it in there for 2 days. It helps if after the first day you replace the vinegar or at least stir it up to make sure your egg is completely covered by the vinegar. And at the end of the second day, you will have that egg with no shell because the acid has dissolved all the calcium. It's actually a little bit bouncy. Don't bounce it too hard though, or it will splat. But if calcium is dissolved by acid, and drinks like soda have a lot of acid in them, what do you think that does to your teeth? Probably not good things. So here's my experiment for you. Take a few different glasses, try to make them the same size, fill it up the same amount. When we do an experiment, we only want to change one thing at a time. So get some glasses and fill it up with the same amount of, say, 1 glass is soda, 1 glass is milk, 1 glass is juice, 1 could be water to be the control, we call it, the one where you're not doing anything special. Try a few different things and put in an egg to stand in for your teeth. And after 2 days, see what did that do to the eggshell. Show what does that drink do to your teeth. So, calcium.
I is for interplanetary. Interplanetary means between planets. Space is really big. It takes a very long time even to get to other planets in our own solar system, planets that are going around our same sun. If we wanted to go from the Earth to Mars, that would be an interplanetary trip. Even light doesn't get from the Earth to Mars instantly. So if light's coming from the sun and it passes Earth, from when it passes Earth to when it gets to Mars, it doesn't do it in an instant or a snap of your fingers. It takes even light 4.35 minutes to get from the Earth to Mars, even though it's going 299,792,458 meters every second. That's over 670,616,629 miles per hour. On a rocket like the ones we have now, we can't go that fast. We can't go the speed of light or even near the speed of light. It would take us about 6 months to go from the Earth to Mars, depending on where Mars is in its orbit. Let's say we wanted to make a model of the solar system where everything is to scale, so the right size compared to everything else. So in our model, let's say Earth is only 1/10 of an inch wide. You took an inch and divided it into 10 pieces, only 1/10 of an inch. Then, in that model, the distance from the Earth to Mars would be 51.25 feet, so 51.25 feet away from Mars, which would be even smaller than 1/10 of an inch in our model because Mars is smaller than Earth. But 51.25 feet, how far is that? Let's see.
It would be this far.
That's far.
Your experiment for the letter I is to create a model of a solar system of just 2 planets. I'll put a link in the description to a chart that you can use to show how far apart to make things. You probably will need a lot of space to make the distance between any 2 of the planets. E is for energy. Energy, it makes things happen. Scientists say that energy is the ability to do work. Not just work like washing the dishes. It's really the ability to do anything, even if it's something fun like playing soccer.
So, energy. And personally, this is my favorite science topic, if I had to pick just one, because energy covers so many different things, so many different parts of science. There are lots of different kinds of energy. Of course, there's electricity, but there's also what we call chemical energy. And that would be like if I used a candle to get light, the candle is burning the wick and the wax. So that's a form of chemical energy. But don't light things on fire without adult supervision. Another kind of chemical energy is in the food that we eat. So where does that energy come from? Because energy can't come from nothing. It comes from the sun. So when the sun lets the carrot grow, it gives it energy, and then we could eat the carrot, and then we could get energy. We could use that energy to do something like pick up a ball. When I bring a ball up against gravity, I'm doing work. I'm using energy from my body to pick up the ball. So when I let it go, it turns into what we call kinetic energy, energy of motion. It's giving back energy. I could give kinetic energy to a pom-pom by using a rubber band. Or I could just send the rubber band flying too. So your task for E is for energy is to find something small and light, like a pom-pom or maybe a crumpled up piece of paper, something like that, and see how much energy you can give it. Maybe you would say, if I just throw it, or maybe I use a rubber band, or maybe a little spoon catapult. How many different ways can you give something small and light like that energy, or how much energy can you give it? You can maybe see how far you could send that little pom-pom.
N is for Newton. Newton was a famous scientist who was born back in 1643. He made many important discoveries, but he's likely most famous for a discovery about how gravity works. You may have heard the story of how Newton was sitting in an apple orchard and he saw an apple fall. Now, he already knew that gravity existed. People had been doing some experiments about gravity before him, but when he saw the apple fall, it started to make him think. He was thinking, well, why does gravity make the apple fall? And over many, many years after that, he found that gravity pulls from one thing to another. Everything pulls on everything else, everything that's a thing. So the earth, a person, and a giant unabridged dictionary are all pulling on each other. You have gravity, the earth has gravity, the dictionary has gravity, but because the earth is just so much bigger than a person or a dictionary, that's why things tend to fall towards the center of the earth. That's why you fall down to the ground and not fly off into the sky. So even though you have gravity and you are pulling on the earth just a tiny bit, it's so tiny a force that you can't really feel it or notice it. But it's still there. Everything that has mass in the whole universe is pulling on everything else that has mass. And more. Besides Newton, there was another famous scientist who did experiments with gravity. His name was Galileo Galilei. And his experiment was to take two cannonballs, one that had twice as much mass as the other, and drop them both at the same time off of a tower called the Tower of Pisa. People thought that if something was twice as big as something else, it would fall twice as fast. So I have here two water bottles. One is filled with water right to the top, and the other is only half full of water. So because this is twice as much water, will it fall twice as fast? Let's see. 3, 2, 1, gravity! No, they fell at the same time because gravity was pulling on them both with the same force. The one with more water would hurt more if it fell on your head because it had more energy, but they're still falling down at the same speed because gravity is pulling with that same force. If I drop this water bottle full of water and something really light, like a wrapper, the wrapper falls a lot slower, but that's because the air is pushing it and moving it around. If I went to the moon, like they did in an experiment on the moon, and held a feather and a hammer, and I dropped them both at the same time, there's no air on the moon to move the feather around. So even a feather and a hammer would fall at the same time, because gravity is pulling with constant force. So here's Galileo Galilei doing his famous experiment, dropping cannonballs off the Tower of Pisa. So your experiment for the letter N is to try dropping different things that are different sizes and shapes and see which ones fall faster. Try to only change one thing. Like I had two water bottles and they were the same size and they were filled with the same thing. Only one had half as much water. If you had two feathers or one was longer, that would be a good experiment. So you can see, well, they're falling slow because of air, but does one fall slower than the other? Why? Is it because of gravity, air, something else? You can design your experiment. C is for color. Colors can be beautiful, but it's kind of hard to explain. What is color? Well, the fancy way to describe color is the aspect of things caused by different qualities of light being reflected or emitted by them. What does that mean? Well, white light from the sun, or an ordinary light bulb, doesn't really have a color that we can see. It just seems to be bright white light. But inside the white light, there's a rainbow. You may have seen a piece of glass that breaks the white light into a rainbow. We call that piece of glass a prism. Or when light is shining through raindrops, then that's what causes a rainbow in the sky. It's the white light from the sun going through glass or water to break it up into a rainbow. So when light comes from the sun, it's got all those colors hiding in it, and it hits something, like in the picture, it's hitting a leaf. Most of the colors are absorbed by the leaf. The leaf absorbs those colors so we can't see them. But some of the colors, mainly green, they don't go into the leaf, they bounce off of the leaf. And they bounce off the leaf into our eyes. So when we look at that leaf, we see the green light. So that's why the leaf looks green.
So your challenge for color is to make walking rainbow water. So you take 2 glasses to start with, and you fill them with 2 different colors that you want to mix. So here I have my blue cup and my yellow cup, and then you start with the middle glass empty. And you put these bridges made of paper towel into the glasses, and then slowly the water will follow the paper bridges into the middle glass, and this will fill up and mix the 2 different colors until the glasses have the same amount of liquid in each one. It takes a while. It starts right away, but it takes a while to make everything equal. And you could even make a circle of a rainbow out of different glasses. So this is the Walking Water Rainbow Challenge.
E is for engineering. What is engineering? Engineering is the process of creating and building structures, products, and systems using math and science. That's the definition from study.com. So we could create a structure like a house, or a product like a bag, or a system. But anytime you're using math and science to create something, that's really engineering. There's all different kinds of engineering. We could engineer better houses, safer bridges, more earth-friendly packaging, water systems that make water cleaner, clothes that last longer, or even a roller coaster that's more fun. There are 6 steps to engineering, according to Kids STEAM Lab. First is to ask a question, or ask what kind of problem you could solve. It's kind of like a scientific method, but specifically for creating things. Then you imagine. So you imagine, brainstorm all the different ideas that you could think of how to solve this problem, or make something really interesting, or invent something. And you can just let your brain run. Just open your brain and write down all the ideas you have. Imagine everything. And then when you have lots of ideas you've imagined, you make a plan. Once you have a plan of how you could start to test your ideas, make something and see if it works, then you can start creating. Then experiment with what you've created. Does it work? Does it work only sort of okay? Does it work great? How could you improve it? So you can change one thing at a time about the thing you've created until you've improved it the best that you can. We call that optimizing. Anytime you use these steps, you're thinking like an engineer, just like anytime you use the steps in the scientific method, even if you're not doing a science project, you are thinking like a scientist.
So your challenge for A's for Engineering is to engineer a structure with paper triangles. So I just got a bunch of paper and I cut them in multiples of 3. So these little ones are only 1 inch on each side. And these medium-sized triangles, each side is 2 inches long, so 6 altogether, 6 inches. And these big triangles on the bottom are 3 inches on a side. So you could experiment with different sizes of triangle, and usually I tried to make all the same size, like each side was exactly 1 inch to make my paper blocks. But you could experiment what would happen if you made your triangle taller and skinnier, if you made these two sides 1.5 inches and the bottom only an inch. How would that build? Would that build a better tower? Would it be easier? Also, I have most of these triangles are just one paper thick. I just took a strip and folded it. But what if you took it and you folded it, you made it twice as long, and you folded it around twice, so each side is 2 papers thick. Or I made it 3 times as long, and I folded it so each side of the triangle is 3 papers thick. You could turn it on its side this way, and then see how much weight you could put on a base made of all these little triangles that are 3 papers thick when they're standing up like this. Might be able to hold a lot more weight than you imagine. So that is your engineering challenge. So that's all I have for you today for Super Science Saturday. I hope you learned something and were inspired to go learn even more. Thanks so much for watching.